Good morning, everybody. It's time to have a little bit of a chat. The reason being that we've gotten pretty far at this point, but we are also waiting for materials right now. We are waiting for the door and windows to arrive, so until then I cannot continue. So I figured it might be a good time to talk a little bit about what we're doing and why we're doing it. This is an 8x8 foot shed. It's that size because that's the size of our previous shed that was termite infested. So we decided to tear it down, and then after that we worked hard on creating a new one, but with a slight difference, as is becoming quite obvious if you follow the build or am watching the video right now. And that's that this is turning into basically a miniature house. So it's doing all the framing that you would do in a real house. So let's start with the ceiling. That might look a little bit odd here. That's because the ceiling is made with 2x4 studs, or rafters if you will, which doesn't leave much space for any insulation. The other problem is that we wanted to have it open all the way. So instead of having the ceiling being where you see the top plate, as you can see here, this is the top plate. Having the ceiling start here, well, needless to say, I wouldn't be able to stand on my toes in here. So what you do then is you do a cathedral ceiling. That's what it's called when you open it up all the way. Now, a problem with cathedral ceilings is insulation. Because if we step outside for a moment, that's the size of my rafters, and that doesn't leave much space. And on top of that, we then have plywood, and we have asphalt shingles and underlayment and all that good stuff. And so it becomes a problem because this will basically cook the roof. So what you do, if you look at our main house over here, it's kind of hard to see maybe, but there are actually vents because you have an attic. But since we don't have an attic, we can't have vents. So what we have instead is rigid foam board that's 2 inches thick. And since 2x4 is actually 1.5 times 3.5 because it's engineered wood, having 2 inches like this means that we leave 1.5 inches for something else. And in this case, what I've done is I've added an inch space between the actual roof sheathing and the insulation. This allows the house or the roof to suck in air here, cold air at this point, and then it has to go somewhere. So unlike my regular house, this is more like a modern house. It has a ridge vent. It's basically a little opening at the top of your roof. You can kind of see that something's going on here because there is a black line. That's because the plywood, it doesn't actually go all the way. It stops right here and leaves an opening. And that opening is actually even bigger in here. And that allows us to install a ridge vent, which is a very fine mesh that's about, I would say, about a half or even a whole inch at the top, which lets air go out. So what we have here is air going behind this. It goes all the way up and gets expelled here, and it doesn't need any fans or anything like that because heat rises naturally, so it's convection that's taking place here. And the other reason for this silver look is that not only are we using foam board, we're using a radiant barrier. If you think about aluminum foil when you cook or barbecue something, you put aluminum foil on it to avoid burning it. So a lot of the heat will basically bounce off of this foil. But, and here's the caveat, if you don't do what we did outside, if you don't add that 1 inch space, it won't actually work. This only works because there's air between the radiant barrier and the actual roof itself. And then of course, I had to caulk and foam where needed, so we create a tight seal. And yes, I admittedly am not the best at this, but so far I'd say it's looking pretty good. Oh, and side note, don't use foam for everything, just use it where you have big gaps, because otherwise you're gonna have to undo it. In some places our sheathing on the outside didn't quite align. There was like maybe a 1/4 to a 1/2 inch gap in some places between the studs and the sheathing. So in that case I sprayed this foam. And it's important to remember that when you use foam, it has to be what's called closed cell foam, meaning that it cannot be open, because open cell foam means it will actually absorb. So it might be great in some cases, but when you can expose it to weather and bugs, you want closed, because otherwise it will get into the actual insulation. Another interesting little detail that probably hasn't been visible in the videos is that this 2x4 is where the window is going to be on, but it's actually slanted. And this is all thanks to spending way too much time watching videos by Matt Reitzinger, the Build Show. He is an excellent source for finding out things you should or you shouldn't do it, but why you shouldn't do it, or vice versa. So he basically said that by doing this, and it makes all sense, if you put that angle like this, there's going to be flashing on this later. It means that if the casing of your window gets water into it, this natural angle will make sure that the water actually flows out. So any kind of moisture will actually be pulled out. Now, maybe we should have had a more angle here, like the whole edge, but unfortunately it was kind of tricky to get that to work. So, sorry Matt, I did my best. And we've done the same thing here. Same concept. For the door, we're obviously not doing that. Instead, there's going to be what's called, I think it's called a sill pan. I do think we have it over here. Yep. So this is a piece of plastic that basically will be the bottom that the door stands on, and it adds a natural grating for the water to run out. And since it's plastic, it will also trap the water and make sure it runs out. Another interesting thing is we have an outswing door, and that turned out to be really hard to find a transition for. But lo and behold, I finally found it. And the really fun thing is that once I got it, it turns out this Assa Abloy. And anyone who has been in Sweden, which has outswing doors by default on all houses, you'll know that Assa Abloy is quite common. Now for the walls, we're going to insulate it with R13. I was hoping for R15, which is the highest insulation you can get for 2x4 space, but unfortunately with the pandemic that's been impossible to source. So instead I went with this one, which was from Lowe's, and apparently the claim is also sound insulating, but I think that's just a property of blocking that space so there can't be any reverberations. And also another interesting part was, we're going to jump out here. So the shed stands on piers, and these piers actually stand straight on the ground. They are not dug, well, there's been a shed there for a long time. The ground is already very tightly packed. It also turns out that there's a foundation, which I think I can show from the side. Here, you can see, let me see that. Yeah, you can see a foundation. So once upon a time, there was a shed half the size, like something like a 4x8. So that was a foundation for that. So the new shed and the old one was standing on part of it, and the new one is too. But unlike the old one, this one stands on piers or concrete. And on those piers are, let's go back so we can see that. You can see quite clearly. There we go. It's standing on 3 4x4 beams, or 3.5 by 3.5, because one thing you learn quickly is that all wood is engineers. All wood is basically 1/2 inch shorter than expected. So it's standing on that's pressure treated, and on top of that is a floor frame that's done with 2x4 16 on center pressure treated wood. And the cool thing with this solution is that I really wanted to have insulation on every single wall, floor, and ceiling. So how do you do that? Well, I wanted it to be open underneath for air. So what I did, let's see if you can catch this. You can kind of see that there's a mesh underneath. That's a rodent mesh. So it's rated to withstand rats and whatever. But what's underneath it is insulation. So what's going on here is actually that we stapled on a mesh, flipped over the floor rafters or joists, and then put pressure insulation into the pockets, and then finally installed plywood on top of that. And just like everything else with the foundation, even the plywood that you see here is actually pressure treated, just like the roofing. But everything else is just regular 2x4 or regular plywood. It does not have pressure treatment. And also the floor is 3/4 inch thick, and so is the roof sheathing. And boy, is that heavy. But for the rest of the shed, we're using regular half inch plywood, which is a lot easier to deal with. And when you cut openings like this, I know people use reciprocal saws and all kinds of things, but what me and my friend found was that it was typically easier, because the way we did, we put you can see it's 8x8, so we put on one sheathing here and then used a jigsaw, electrical jigsaw, and just cut it out with a speed blade. And that was by far the best way of doing it, because it gave you really good control of how your cuts were going. We also installed flashing, because one thing with the old shed was it had no flashing. So yes, my work is a little bit not the best always, but again, this is my first attempt building a house by myself, because I might be calling it a shed, but we're doing all the things that you would do on a real house. So it has the flashing. You've been seeing a lot of electrical cords in here, and that's because this shed is not going to be powered by the house. It's actually going to be self-sufficient. So the black cord you see coming down through the top plate there is actually going up, and this is going to be hard to show, but it's actually solar panels up here. 400 watt solar panels all connected together, and they will go in here onto this sidewall here, and on that one there will be MPPT charger from Venergy that will charge 200 amp hour 12 volt batteries, which will be on the floor or close to it anyway. And then there will be a 12 volt system, which you can see from the black and red cables that's going everywhere here. So that will be powering all the lights. And if we go inside, it will also power USB chargers, because it turns out that if you look at marine or RV things, you can easily find Qualcomm Quick Charge 3 that is powered by 12 volts. So on this end and also on this side, we will have chargers. They will always be available. They will always be running off 12 volt, which is kind of nice because that's more efficient. There's also going to be 110 or 120 volt. There's going to be a total of 3 outlets on the inside. There's one behind all this insulation. And that's all going to be powered by a 1000 watt inverter. And that's going to be connected straight to the batteries. But the really cool thing is that while it's connected straight to the batteries, the actual output for the inverter is not connected straight to here, because you would expect it to go to this. But it won't, because there will actually be what's called an automatic transmission switch. We're not talking about a car transmission, we're talking about electricity. So you see this hole here. This is where this cable will be connected to a reversed outlet, meaning that we can pull an extension cord from the house to here, and then we'll go into the ATS, which will then, if it detects power coming through shoreline, because this is all of course RV and marina equipment, it will then switch over and run my outlets off of the house power. And if there's no power coming in, then it will default back to my 1000 watt inverter. And there will also be a fuse panel for all the 12 volts, because we have 12 volt going to the overhead lighting, which is going to be 12 volt LED lighting, very similar to what you have in a real house, but it's actually meant for RV, but it looks like real. But the benefit is I think it's about a ½ inch thick, so that's why this works. But as you can see here, there's like ½ inch here, and then the gypsum, the drywall, is about a ½ inch. That gives you an inch or a ½ inch. I'm actually not entirely sure. I think it might be a little bit thinner. But either way, it will be able to fit here, and that will be controllable from here with a regular Decora switch, so it will look like a real house, but it's actually running off 12 volt, because 12 volt or 110, it doesn't really matter. The switch is just a switch. There will also be an outside light, which you can see here, outdoor light. There's going to be a hole right here, and I had the same kind of lighting that I have on the house over there. It's going to be in the shed as well, because the cool thing with that is that once you remove their internal transformer, those lights are actually 12 volt, so they will be connected here as well. And you will have, and this is where I'm debating, there's going to be a switch for it, but most likely it's going to be tied into the solar charger, because it turns out that the solar charger has this really cool feature that it has a load output that you can configure, so it will provide 12 volts when there's no solar. So that means you can have the light turn on when it gets dark without any extra logic, any extra circuits. But I probably still want a switch to be able to turn it off. Yeah, and then there will be a circuit panel, the same kind you see in boats and RVs, so car fuses, but still, I mean, it's 12 volts, so that should work just fine. And then there is a extra cable going all the way, and then it goes up here. And that's in preparation, because I don't know how warm this shed is gonna get. I mean, we're gonna have double pane windows, we have R13 all around, it's gonna have house wrapping and caulking and everything to make sure that it stays nice and cool in here. But that doesn't turn out, or it still gets too hot, then the idea is to have an exhaust fan up there powered by 12 volt, and then likewise down here there will be an intake, but it will be a passive intake. So basically, because of the exhaust fan creating a negative pressure in the shed, it will automatically pull in cold air, so pushing out the hot air from here and then pulling in hopefully cold air from here. I do have some really geeky ideas of using temperature sensors and basically run the fan anytime there is a temperature difference that makes sense. Like if it's 60 degrees outside, but we're measuring something like 70 or 80 up here, then the fan starts automatically. But if it's warmer outside and inside, then the fan will turn off, just to make sure we don't pull in hot air. That was one more tip I learned. So when you are leveling things, you need something to level with. And the recommendation I found was to actually use asphalt shingles, which is what you see here. These are actually asphalt shingles, because they won't compress. They're asphalt. They won't go moldy because they're asphalt. So they turn out to be the perfect material for leveling your shed. And I would really recommend spending the time to leveling it, because if you don't get your floor straight and level, then everything else is going to go progressively worse. Right now, the schedule looks like we are going to get the windows and the doors this upcoming week, and then hopefully next weekend it can get installed, which means that we're going to have to do the house wrap. Basically, you put a membrane around the whole house. You slice the openings in an X, and then you tape things down with flashing tape, which is a very special tape. And for those wondering, it's freaking 9 inches wide, so that's one heck of a tape. Once the house wrapping is in place, we can install the doors and windows and seal those with foam and caulking and everything, so that creates a tight seal. Once that's done, it's time to install the external siding, because yeah, it's not going to look like this. And once we get to that point, most of the work remaining is actually on the inside, and it's time to insulate and prepare the drywall on the inside. And this is also the reason why I haven't installed these electrical boxes, because I realized that it was way too convenient to cut an opening from the inside. So instead of installing the outlet now and then having to figure out how to cut a hole in the siding, I'm just going to install the siding right across and then just cut right through it, because that just saves time and frustrations. So yeah, that's it for this time. Hope you enjoyed the video. See you soon. Bye.